Next up, actually, why don't you load while I introduce? Happy to introduce Austin Gibbons. Austin is so many people here.
Hello, I am from Quantifind.
Right, so Quantifind is one of the champions of the Spark community. Don't let the fact that I couldn't remember the pairing between all of these speakers and their organization mislead you. Quantifind has been involved from the earliest days of the project and is one of the first companies to bring it as a startup, to integrate it into the core of their business and to bring it to production. So they've given many talks along the way to keep the community updated. They are a champion in the community as an organization and as individuals, and I'm excited to hear from Austin.
Thank you very much, Andy. So yeah, my name is Austin. I work at Quantifind, and today I will be highlighting how we use Spark within our analytics platform. We've been using Spark across many different parts of our suite of products for 2 or 3 years now, and I'm going to really focus on how we use it rather than just why. So before, in the beginning, this was kind of our development environment. We had many different data scientists who used Spark differently. I grossly preferred the REPL. A lot of people would just make executables and run it. And we used common utilities, of course, but we would sort of do this independently. And we would read off of HDFS, store our own things in RAM, and go forward from there. And this, of course, has the obvious problem that we are using more RAM than we need to. Right off the bat, that is the biggest thing. So we try to fix that. And that'll be what I'm talking about today with Laburnum. We realized that we can just cache the data once, and then have many users read from the shared cache data, and then that'll enable us to only cache the data once, save a lot of RAM. And once we do that, once we have an environment where people are using a shared structure anyways, we can also create shared output environment. So this is a very simple thing, and Spark is just one part of it, but it is the driving use case of it. So the way it sort of works is there's 2 parts. There's this lab's core structure, and then services. And services are what the data scientists will write, and labs is what a single person will create in order to enable the sharing of RAM and so forth. So it's pretty simple, and I'm going to highlight 2 things. I'm going to highlight hopefully how it's simple. It's simple for people to consume things on the other side. It's simple for people to use the system, and once we have people using the system, then it also becomes powerful and flexible. So this is what it looks like for our analysts, our marketing people, our product people. They go to a web browser. There's a list of applications on the left side. You click one, you click run, and then you get back some output. And that's one of the powerful parts about this, is that we create this common set of utilities and visualizations and so forth for people to use. But I really want to highlight that it's simple for the people who are writing the applications. And I'm just going to plug something that we use internally called Sumac, which is an argument parsing library. And this is what we use to pass information across Laburnum itself and these services. And it really is excellent. I highly recommend you check it out. But for right now, just trust me that it is a very simple way to pass around information. So this code I'm not going to go into, but is a complete and working example of labs. So this is a very small example I wrote for this talk, where you have a list of actors and all the movies they've starred in. And what this is doing is it's using Spark, it creates an RDD, it caches it, and it exposes it using Sumac so that other people can consume it with services. And one of the beautiful parts about this is that when you start this lab service, you start it running in cache. Only the person who actually has do this once, to cache the data once, to expose to many people, has to deal with the rest of the Spark environment besides the RDD. Only one person has to know where your cluster is, has to set the memory requirements, and so on and so forth. And that really just helps the data scientists focus on just having an RDD and doing stuff with it, rather than having to worry about the rest of the environment, such as, is my REPL working? How do I launch a job? All that sort of stuff. So this is an example of a service, and hopefully you see it's pretty simple. So there's a small amount of boilerplate. You have to define some input, you have to define some output, but then after that you just sort of get an RDD. So just calling args.actors is how a data scientist then gets the that cache thing of all the movie stars and the movies they've portrayed in, and then they can just write their application. They don't have to worry about the parsing, or they don't have to worry about the environment, they don't have to worry about setting RAM, all that sort of stuff that is kind of a headache, because that already was done by someone else, because they know that many people within the company are going to want to look at the RDD they procured about movie stars. So now hopefully you believe that it is sort of simple and flexible. And I want to highlight that it is flexible and powerful. Once we have people working in this environment, we can do a lot of those more powerful things that we started to describe. In addition to visualization and having a common web browser that we can very easily expose tools to analysts, we can also make it more powerful and flexible for the people writing both labs and the services. So it really is flexible, and I want to highlight that you aren't tied to having to go through the web browser just because you wanted to share that cached data. Because it extends this thing called argmain, which is something we take from Sumac, you can just run it as a standalone service. For that person who just wants to create a jar, click run, and see their output, they can still do that. You still get all of that. And then very exciting is that Labs isn't tied to any one technology. Spark was our driving use case and the core thing that we do use it for. But if, heaven forbid, one day we stop using Spark, we could just comment out with Spark Plan. Or if we stop using Mongo, we can comment out with Mongo Plan, put different technologies, we can put different databases and so forth. And we can sort of mix and match in this way. And that's something we do now. We have one thing that runs Mongo and one thing running off MySQL. And those are just sort of different, but they still run in the same analytics environment. And then one of the most exciting parts is that because we have now this sort of independent entity that cached the data, it wasn't tied to a single application, and it wasn't tied to a single user's experience of using that RDD, we can make it dynamic. So we can have someone who comes in new and they join the company later, or they just want to explore the new data set that people are looking at. They can just show up, they can write their own code, and we can compile it for them, dynamically add it to the class path, and then expose that to Spark. And this has a really powerful implication. So hopefully when I convinced you that it was simple, part of that was that there's really a small amount of boilerplate. You have to define the arguments, you have to have some sort of output, but then you just take the RDD and you start coding, and you don't have to worry about anything else. And the powerful derivative of this is that you can do stuff from the REPL. So we modified the Spark shell to support having args exposed for you. So this is a small example. You can say, all right, we realize that actors aren't the ones actually making any money. We are pivoting the company. We're going to look at movie stars, or we're going to look at the movie companies instead. I need you to do a new application. We have a new business need. How quickly can you tell me all the people that Tom Cruise played in a movie with? Or can you tell me how many movies there are, how many actors there are? Well, we can just open up the REPL, which is, as some people want to do. They don't have to go through the browser or through packaging in the jar and running it as an executable. They can just open up the REPL, call .count. They can call map, reduce. You have all this Spark functionality. We add the boilerplate for it. We compile it for you. The job runs, hopefully. And because we're compiling it and we are running it like this, it isn't really the same as an interactive shell, but that is something we are trying to make better. But the idea is that you have these large cached data sets, so you still get that huge benefit of you're already working on cached things, and then it returns the data directly. And that is the bulk of Labs. So I want you to take away that it's simple, it's flexible and very powerful, and we are looking to open source it, so get in touch if you're interested. But I want to really highlight that it's simple, we're sharing things amongst users. And you might be aware of some other technologies that are coming out of the AMP Lab and other places, such as, why don't I just use Shark if I just want to make simple queries? Well, we are exposing more powerful queries. And why don't I use something like Tachyon is another great thing. Well, that is sort of, frequent caching and things like that. But a big part of Labs for us isn't how we use it, is we want things that are highly available. Because we're sort of manually managing the memory, whenever Megan shows up to the party, we are still using this, it's still cached there, and we can still say, great, this is highly available and it's important that this is available. So we have that sort of memory management for you. But then also we can just layer all those things on as well. We can add Shark or we can add new technologies as they come along. Cool, so I went pretty short because I didn't have much to say. But yeah, if you have any questions, I can take 2 minutes to answer them, and then we'll be caught up with track B.
We are actually caught up, so we have time for a question or two.
Yeah.
Can you stand?
How many users are actively using the system?
So we only use it in Quantifying right now. We're going to open source it hopefully in early spring of 2014. And there are there's like 12 engineers total, and 5-ish of us use this in some capacity, just because that's what we work on. Yeah. So it's a small set, but okay. That's a start, sure. Cool. Thanks.
Yep, let's thank him again.